with the live in-person thing. It's like that. See what I mean? My name is Brian Sheldon. I'm an Earth and Environmental Science teacher at Livonia High School. I'm going to turn this over to Ray Case for a second. He'll give you a quick introduction here, and then we'll get rolling.
Okay, thanks, Brian. Yeah, well, welcome everybody to the Watershed Education Center. This is by far the largest crowd I think we've ever had in here, so we're setting records all the time. Plus, we have about 30 people out in the Zoom world watching this also, so this is a big deal. Just to let you all know, this is a second or third time we've used our new AV system, and the way the new AV system works is those green lights in the ceiling are microphones, and they can pick up sound all over the room. We also have some cameras we can try to do things with, but mainly we're going to be looking at the screen. The thing about the microphones is they are sensitive, so it's best to not be doing a lot of side conversations during the presentations, because that would get picked up and people on Zoom would hear it. Likewise, for all you folks out there in the Zoom world, you should really mute or stay muted. Later on, if we get to the point where people can ask questions or want to ask questions, you can hold the space bar down where you're talking, like the old CB radio deal where you hold the button down and talk and then let go of it. Well, the space bar works the same way. So the other couple just logistic things here, there's a fire exit, the big double doors over there, the one you all came in, and this one back here, just in case. There's one bathroom that you could use. There's bathrooms across the walkway in the park. So if you get multiple people need to use the facility at the same time, you have to go out there and use those. So that's pretty much the intro. Again, welcome everybody. It's great to see such a big crowd. When we wrap up, I think, we'll probably, you'll probably all get an email from Charlie asking you to fill out a little form about, what you thought and how you liked it and any second suggestions you have about this presentation or future presentations. We're always looking for input in that regard. So I think we're good to go.
All right.
You're good.
Thank you, Ray. Yep. So again, thank you everybody for coming out. I really appreciate that. This is the crew that is going to be talking to you tonight. You can see it's a relatively large class. Certainly one of the biggest ones I've had, and that's been a challenge, but it's been great. I would tell you, regardless of the size of the class, my number one goal is to try to help kids get in tune with nature. And there's really only two ways I think you can do that. One is you got to spend a lot of time in there. Hey, Katie. You got to spend a lot of time in it. And then two, you got to spend a lot of time purposely looking at it. So one of my favorite quotes, and before I show this, actually, let me just say my opening activity this year was just taking a leaf. I took a leaf off, I took several leaves off of the same tree and I handed it to each one of the students. And I said, your job, hey, hi, Elliot, I saw you too. I had them study that leaf for 5 minutes. They just had to look for minor details, right? And try to see patterns and ask questions. And with that in mind, this is one of the ones that came out of this. It ended up really being a fantastic exercise. So I just want to point out, I don't remember whose this is, so one of you can claim this back there. But we got this little brown spot here, and you can see they matched it up quite nicely there. You got these little patches down here, and you can see they matched it there. So I was really impressed with this, and I was like, wow, this is fantastic. That was the first one off the pile. And as I started looking at this, by the way, one of my favorite quotes, attentiveness alone can rival the most powerful magnifying lens. Very true. And down here, I know it's fuzzy, but I had them break down after they did this activity to just kind of say, hey, what'd you think? And this says, I thought it was okay because I don't really focus on things long enough to realize how interesting they really are. All right. And so that's really one of my main goals with this whole thing is just to have students recognize you don't have to go far to see beautiful things. Classic. And so this is a quote from my daughter, like, wow, they actually tried. It was amazing. After I peeled off one of them, the next one was better, right? And I peeled off another one, and it's another awesome one. And so I became so enamored with this that I literally ended up putting all of the papers down on the table and mix up all the leaves and then purposely challenged myself to try to match up the leaves to the drawings. Fantastic exercise and really proud of all of them for how they did with that. But don't get this confused. Really important that you all recognize this is all about me. It's all about me. I say that because I am honored and truly thankful for a bunch of people that makes this course possible and for it to be what it is, right? It is definitely an unusual environmental course. My administration, has given me freedom and trust to go and do things that I don't think too many schools have the opportunity to do. So my admin and in particular, Robin Carl, she's my go-to person. We have a lot of things that happen on that campus and I'm always calling her up, asking permission. Can I do this? Can I do that? And she like hops right on it and gets it to me. So I'm very thankful for that. Bill Vogt this year was our chainsaw guy. He came out there and you'll see some of these presentations. He came out on really cold days, snowing days and cut some trees for us. Our reviewers, they're in the room tonight. We have Keith Lyons, Bill Lewis, and Linda Artruse all came in for a practice run over a week ago to give these kids suggestions on how they could make things better. And that was really a very productive session and I'm thankful for them. Ray Case, you were also here, so thank you, Ray. Charlie Braun, who is not with us tonight, but he's the one who's kind of controlling the Zoom board here. Really important that I want to recognize him, right? Because this room is actually named after Charlie. He's been a steward of this lake for many, many years. And ultimately, he's the reason we're sitting here in front of you now. So I just want to make sure that Charlie knows he's out there and being recognized.
Thank you.
Some people in particular, and this is really the joy of this class for me, and I say it's all about me, and what I really mean by that is I get to learn through them, right? One of my objectives is always to bring in professionals from outside who know a lot more than I do, to teach me a whole bunch of stuff about the things we have right on campus. So the first one we had this year is a person named Bryce June. He's a forester right here. These two have been coming out for several years now. I'm really indebted to them. This is Matt Havens and Zach Warning. They're both from the Natural Resource Conservation Service. They come out every year. They literally take their time off of their day. They're not okay to come out there in terms of pay. So they're taking a pay cut to come be with our kids, which I just think is like really, really awesome. And then Dr. Jackie Malinowski helped us this year with the microscope. You're going to see some images from that microscope this year. And then a gigantic thanks. This is just to give you a little slice of life here in the environmental class. You all know having just 1 or 2 teenagers is bad enough. Try having 23 of them and see what that looks like, especially after going mucking, as they like to say. So really indebted to the custodial crew. It's not just the outside and the hallways, but it's literally like that's pretty much what our back desktop has looked for several months now. So always cleaning up after me. I appreciate that. Course objectives. This is a little bit different course in that we're not doing standardized tests or anything like that at the end. So the idea is 3 objectives: learn how to perform genuine research, collect data that can then be utilized by the community, and lastly, communicate research publicly outside the classroom. And that's what we're sitting here doing tonight. So again, I appreciate all of you being here. Just to give the kids in the back a little sense of who's here though. Oh, I forgot I put this in this year. We're going to try something. Cell phones, I know we didn't say this, but we'd be really appreciative if you turn the notifications down so that we don't get interrupted during the middle of this. Some people in the past have asked us for the slideshows and they end up emailing me and I don't even know who these people are and I'm trying to send them stuff. So just for kicks and giggles, if anyone out there has a QR code reader on their phone, give that a shot and see that is literally linked to a copied folder of all these slideshows if you're interested. And you all can tell me. I have this funny feeling that it's going to say you're going to have to request access and then it's going to be on me anyway.
It worked.
It worked? Yeah. Does it open the folder? Can you actually see the slideshows?
Yeah.
Yes. I'm done. See ya. Mic drop.
Brian,
Okay. So tonight's process, real quick, we do have a lot of people here, a lot of students to present, so I'm going to try to keep this really short and sweet. You're welcome to take pictures, just please keep the phones down. Please ask questions after the presentations are over, so that, and we've adjusted for a little bit of time in there for you to ask questions, and please ask them if you have them. It's important for the kids to hear them. There's a lot more behind these presentations than what you see. So there's always things to be learned and give them an opportunity to show off what they know. It's gonna be a long one, everybody. Just because we have so many groups this year. So in between, when we're doing transitions, I encourage all of you to stand up, do some jumping jacks, something to get the blood flow. I might force you into doing that. And then lastly, there is a survey at the end, as Ray said. So we'd appreciate you filling that out, giving us suggestions how the WEC can do a little better, and then maybe how ideas for us as the Livonia high school environmental class, things that we could do. Okay, last thing, and this is so I want you to raise your hand. You can raise them for more than one. This is just so the students in the back can see who all's in the audience for them. Okay, so here's a parent or sibling or presenter. Raise your hand if you're one of them. There we go. Teacher, past, present, or future. Raise your hand if you're one of them. Look at that. Current college or high school student. Nice. Interested community members. That might be all of you. Fantastic. Livonia admin or board members. Wow, look at that. Thank you for coming out. SUNY ESF faculty or staff. Whoops. Hi, Amy. And having interacted with these students directly, including bus drivers. We actually didn't do too many field trips this year, but we definitely, hey, we had one. She even bought her kids McDonald's. It's like fantastic. All right, so we got everybody. Last thing, I just remembered, I was asked to announce that the Canisius Lake Association does every year offer scholarships. So it's 2 scholarships. I think we have a past scholarship winner here. The deadline for environmental students is April 1st, right? And I'll be getting some of that information through an email and send it off to all of you, but the application will be out there. And what's the price? It's $1,000, $1,000. Okay, so there was 2 of those. One went to us last year and one went to SUNY Geneseo. So with that being said, here's how this is going to run. The students will come up and then I'm not going to say anything in between. I'm just going to let them come up and take care of business and do it as we have practiced. Okay, so our first group, come on down. Oh, I have one more side. Thanks for coming out. We hope you dig it as much as we did. There you go. I don't know if we need to. Does anyone of you want pointers or stick pointers? Because I brought those. Yeah, you gotta have Charlotte Boyd stick pointers. It's not any stick pointer. Don't break that. Which one of you broke the one today?
I think that was open. Yeah, we don't. I don't think that was us.
All right, like you got it, right? All right, man. Turn you loose.
Oh, we need a clicker.
It's gonna be that, the one you've been practicing with all along. Yeah, so.
Good evening, thank you for joining us. I'm Mike Neckers.
I'm Owen Cabo.
And I'm Matthew Charlebois. Our project is titled the Successional Mapping Jamboree. Now, through this project, when we started out, we set some goals for ourselves.
Take a look at our goals. So first, we wanted to create a map of Livonia's campus showing property lines and classifying and identifying the plots for topography, soil, and forestation. Then another one of our goals was to record and develop stages of succession and land use history on Livonia's campus. So let's see how we divided up our campus. We divided it up into 4 quadrants. First, we have the northeast quadrant, which has our school parking lot, our cross-country trails, and our disc golf course. Next, we have the southeast quadrant, which has some mature growth forest and our wetlands. This is personally my favorite quadrant. Then we have our southwest quadrant, which has some medium growth forest and has some sports fields. And then finally, we have our northwest quadrant, which has a majority of our high school and some more sports fields. So topography has been a very influential part in affecting land use history in our area. It determined where farmers grew their crops and where we built our campus today. So you can see here, we have 2 elevational highs on our campus, and we have one here and one down here, which are both about 370 meters above sea level. Then where our campus was built, it's a little bit more flat. It's about 350 meters above sea level. So these 2 elevational high points are actually drumlins. So you might be asking yourself, what is a drumlin? So about 13,000 years ago, the continental ice sheet, thank you, came down from the north and proceeded right over our area. As you can see in this diagram, it shows the continental ice gap, and you can see Canisius Lake right up there. And all those little elevational high points, all those little dots are actually all drumlins. So you can see this is what they look like, and you can see actually similar to our campus, it has forest growing on it, and a farmer was once growing crops on that one. So very similar. So how are drum ones made? So when the glacier came over the land, it started to churn up all the rocks and soils. And as that started to build up, it would then be deposited into a mound-like structure. So the structure is actually made out of what's called glacial till. So you can see the two drum ones on our campus here, represented by the two red dots. They're both elongated elevational highs positioned in the north-south direction. And that's what it looks like. And then, so the glacier was very influential on what kind of soils we have on our campus. On our, oops. Okay, there we go. On our drumlins, we have Hilton loams, which is about 67C and considered 67B. Then on the flatter parts of our campus, we have a silt loam. So let's see what that means a little bit further. So using the soil texture triangle, we were able to identify composition of these soils. So reading across, you can see it's about 20% clay, and reading up like this, you can see it's about 45% silt right here. And then it's about 35% sand. So this composition of soil is very versatile. It was really great for farming. It's very balanced between all the different soil compositions. So that's why a lot of our land was used for growing crops. So let's look at a primary succession. So when the glacier came through, it left the land very barren. It was, and then as time progressed, as soil was able to be built, we saw some younger growth forest, some intermediate growth forest, and then we transitioned in some mature growth forest. So now let's take a look at secondary succession. So then what happened was a disturbance happened. In this diagram, it says a fire, but in our case in New York State, it was the settlers that came in and deforested most of our state to farm on. So after that happened, it was a younger growth forest, lots of fields, they were growing crops. As time went on, we didn't need that much land for farming anymore. We started to see those intermediate and older growth forests come back. Here's just another diagram of that. You can see where the glacier came through. We had our growth, we had our disturbance, and then our growth into a climax forest again. So let's see what we have on our campus. So here we have a mature growth forest, which is composed of a lot of big trees, a lot of oak trees, stuff in that nature. And then we have our intermediate growth forest, which is a little bit more dense. Actually, right here is our dead ash forest on campus. Then we have our younger growth forest over here and here, which a lot more light is getting through that canopy, hitting the forest floor. It's a lot more dense, and there's room for an invasive species and a lot of shrubbery, stuff like that. Then we have our fields on campus. And then finally, we have our wetlands, which we'll go over a little bit later in our presentation.
All right, so now we'll dive into our campus and how it looks today versus how it did earlier. So in 1954, you can see our campus existed, but not to the extent that it does today. So we've got our common building over here, our softball field, which is labeled right there. This is where our school is today. You can't see it there because it's not built yet. Got our fire hall down here, and then obviously Bulldog Boulevard wraps right around our school. So we'll start with our northwest quadrant. Now, our northwest quadrant was very interesting because of this softball field. A lot of these sports fields that we have today are still fields, obviously, so it's kind of hard to figure out like where the property lines are, things like that. So a big indicator was this field right here, and then this triangle shape, which you can even see over here. So we started in 1954. You can see we've got a whole lot of hedgerows. They're not very dense, not a whole lot going on. And obviously that triangular shape with a hedgerow there, but there's no forest or anything. Moved to 1974, and you can see, maybe it's getting a little more dense. You can see the ground here is a little bit darker, so there's obviously some shrubbery growing there, got some hedgerows, and obviously our school was built. Move to 1990, you can see maybe this part has been let go a little bit. There's trees starting to grow here. This is still not forest yet, but there's some more shrubbery. These hedgerows are getting a lot more dense. And then we move to today, you can see that this triangular shape that I talked about earlier has grown into a forest. So we'll move down to that, and as you can see, there's just a better view of that triangular shape, and it started to move this way a little bit even, creep, and you can estimate that was about 30 to 50 years of growth. So I'll move down to the ground. So down by Wilkins Creek, we found a stone wall built by farmers, which was interesting. It actually went all the way down the hill, so it went from here all the way down to about here. And then when we went over here, you can actually see, it's not a great picture, but there's a little ditch section there, and then the wall is right over here in relation to the photo. Next, we'll go to our northeast quadrant. That's home of our disc golf course and our cross-country trails, as well as our oldest forest, some of our oldest forest, that is. So in 1954, you can see that forest is here. There's nothing up here, just a lot of fields, a couple of hedgerows, nothing super defined. Move to 1990, you can see these hedgerows have gotten a lot more dense. This forest has actually started to creep a little further east, which means it's growing. And then obviously still fields here and here. And then move to today, you can see we've got a young successional field here, a little bit of medium growth forest, and then obviously our oldest forest on campus. So in 1954, we'll look again. You can see these hedgerows. 1974, which was not shown on the other one. You can see that this field is clearly being used for farming. You can see the lines where the farmers have put their crops. And then we've got our forest here, which is starting to grow. Move to 1990, you can see it's moving east. These hedgerows are getting more dense. And once again, you can see these are getting a lot more dense and growing into young forests. So we'll move down to the ground now. You can see right here, Matthew and I went and we found a barbed wire fence that actually went quite a ways up the hill. Then we've got some stones here, as you can see, was actually went quite a ways up the hill as well, which are evidence of a farmer there who built a wall and also some glacial tip. All right, from an aerial view, you can see obviously our disc golf course and our cross-country trails. And this funny story is actually a dump site for the town. This used to be the water tower. They moved it up to there and they made the old location a dump site. Now I'll send it over to Matthew and he'll do the 7 quadrants.
So the southwest quad had 4 distinct farmer fields then. This was also a field over here. But the one you want to keep on is field number 4, because this one was let go first. So it has the oldest growth out of this quadrant. So you can see in 1954, it's all fields. There's 4 lines here. And in 1990, you can see that this field was clearly let go first. It had a lot more growth. It looks like these fields are starting to stop being used. You can't see the distinct vertical lines that show the farmers' fields. And it's just interesting to see. Now in present day, you can really see these lines from the air and the ground. From the ground, there's these topographical highs here that are caused by the farmers. They would get all the stumps and rocks from the center and put them on the side, and the stumps would decompose into like dirt, and the rocks would stay there too, creating these mounds. So this was a distinct mound here that was running this way along this field line. There's another one here that's running along this field line right here. And then this, you can see that there's a bunch of trees here, and there's just no trees over here, showing that there was a line here where the farmers were farming up here while this was let go, causing the trees to grow. Here's another, it's hard to see on the picture, but there's a big topographical high going down this hill, and there's a lot of rocks on there and old growth trees, showing that there was a hedgerow there at one point. So from these pictures, you can really see how this field here was let go first. And in this part, it's probably an early successional field, and here it's a young growth forest. And today it's the oldest growth forest, and you can really see the distinct line here and here showing the field's growth. So again, you can see the distinct lines on this field from the air and owns around. So now southeast quad, the most important, interesting part of this quad is the wetlands here. Because in the 1950s, the farmers, they couldn't farm in the wetlands because it was too wet. So they ditched it. So there's 2 ditches here that went into Wilkins Creek that runs this way and up there. And in 1954, you can see that this old growth forest is not being farmed. This part was being farmed and the wetlands was drained. So there was no wetlands there. In 1990, you can see that the fields were let go. This is probably about young growth forest, and the wetlands is now prominent in this picture. And you can see that even growth expanding this way. And this line right here is another very distinct line. So On the succession, you can see the state line over the wetlands, how the forest expanded this way more, closer to 1990. And then today. From the ground, on this line over the wetlands, there was the farmers had a fence that they stopped using. And you can see that there was a pole here and one here, and there was a barbed wire line still running through the fence. It's all like underground, but it's still there. And then another thing you can see is this line going here. This picture was taken like here going this way, and you can see that there's a old growth forest here, young growth forest here. You can tell it's the edge of the forest because the old growth trees are growing out this way, while in a normal forest where it's in the center, they would just go straight up because there's no room to grow on the sides. Now I'll give it to Owen so we can go more into depth on the wetlands.
So our wetlands are a pretty cool part of our campus. It helps filter our waste from our high school parking lot and provides habitat for thousands of species. So actually in this drone picture I took, you can see the two ditches over here where the farmers try to drain this back in the day to grow their crops. There's actually a beaver's dam right here located that Mr. Sheldon pointed out to us. And then going into it a little bit further, we wanted to conduct a little experiment to see if we could find the post. And so we dressed Michael over there and Matthew up over there in full orange gear. They went to both opposite sides of the wetland and they both tried to find those posts. So we drew our line, we found the barbed wire fence that was a bit buried and drew our line. But then we started to notice, why does the vegetation look? It looks different at this section. It creeps down and it's different from this section. So this was actually because this half of the wetlands was farmed while this half wasn't. So the vegetation is starting to actually creep down to the lower parts of the wetlands. So we predict maybe in the future the whole wetlands could be this older vegetation. Here's just another diagram. We have the whole wetlands was drained by the farmers, but only the bottom section was farmed, and the top section, we thought maybe it was used for pasturing animals or other types of things the farmers might have done. All right, so what we've accomplished with this, we discovered how glaciers impact the elevation in our area. We've identified and mapped property lines using aerial photos, old hedgerows, and farmers' fields. And finally, we explored how succession has changed land use over the years. Moving forward, we can shape young forests and fields into thriving ecosystems by limiting the spread of invasive forests to encourage native plants. We can examine changes in ecosystems surrounding the new bus garage, which other groups will get more in depth in that, but just wanted to mention that. And then we can track changes in our campus in light of many renovations proceeding in the coming years. So some of our citations for this project were, we used the GIS mapping database, was very useful, the Livingston soil database, and my DJI Mavic Mini 2 drone to get those aerial shots. Thank you. Any questions?
Bashful.
Where'd you obtain the old pictures of the aerial views?
We got those from D-Shell. I don't know. I think he went to like the, I don't know, town hall or something to find them. That's more of a question.
So Livingston County Planning Department, and it was the natural resource. In fact, I should have thanked him. Bob Stryker is his name. He works for National Resource Conservation.
They had aerials back then. Pretty neat that they had aerial.
Oh, they got them over back in 1938. Well, they're taxi back in the early 30s, and they're not great photos. But yeah, so the earliest aerial photo I saw was 1938. It's amazing what's happening out there. All right, good job, you guys.
They're switching, the folks standing in the back, there's a couple seats up here up front.
Good job, guys.
So you had like 15 of them.
Everybody, when we go to transition, I do encourage you to stand up and get some blood flow. It's gonna get tired. I have a lot.
I lost track. I lost track.
Okay, you guys ready? All right, we're ready for the next one.
It's good. Hello, and thank you for joining us. My name is Sean Chapinski. I'm Cameron White. I'm Logan Chafee. And we'll be cleaning your boots and challenging your minds. Now let's move on to goals. So what are our goals for this project? Our first goal was to document the invasives that we found on campus. Our second goal was to research the effectiveness of boot cleaners. And our third goal was to design a boot cleaner for future building. So what are invasives? So they are species that are non-native to our locations. They also outcompete the natural species. And as you can see in the picture, these are Phragmites, which we will describe it later, but you can obviously see that they are overgrown and blocking many things.
So this is an invasive species curve, and this is used by a lot of America to document invasive species. And as you can see, over time, the cost of controlling an invasive species in the area infested increases over time. And the first stage of the 4 is the prevention stage, and that's a good stage to be at because if the management of the area is good enough, then you can stop the spread of invasive species by not allowing them to get in, and you can usually do that by boot cleaners. It's a good method. The next stage is the eradication stage, and that's very important because when someone needs to eliminate the species, it's at the weakest point because not a lot of the area is infested, and you'd like to keep you like to eradicate species that way. They're small and they're very countable. The next stage is the containment stage, and that's not a very preferable place to be in because at that point an invasive species has spread over a large area, and the chance of immediate eradication is very unlikely. And the last stage is long-term management, and this is the final and worst stage. And at this point, immediate action is too costly and is practically impossible, and it's given up on. And at this point, it's really about protecting resources you care about when the invasive species come upon it.
So how do invasive species spread? Invasive species spread in 2 different ways, natural and human spread. Natural spread by wind and water currents. In animals, mainly birds, due to them eating seeds, eating berries, and spreading the seeds through defecation. Now human spread is through shipping industry, pet and plant cells, and recreational hitchhikers. Now this is a bad thing due to the fact that our campus has many different trails. And them picking up these seeds easily lets them spread them like wildfire. So here are so we are focusing on the east side of the campus for invasives. Now in the northeast, we got cross-country trails. In the east, we have disc golf course. In the southeast, we have the old forest. So here are all the invasives we're going to be looking into on the east side. And they're color-coded, and this is mainly general locations of them. So what's our first invasive?
So our first invasive is a more honeysuckle. It's a perennial shrub, 6 to 15 feet tall. Its leaves are egg-shaped, as you can see here, and they're 1 to 3 inches long. They produce 1/4 of an inch dark red berries during late fall, and they have hollow stems, as you can see in this picture right here. And their seeds are spread by birds eating their seeds, and it spreads out by defecation, like Sean said earlier. And the berries are poisonous to humans and animals. If you have a dog, you probably shouldn't be letting them eat those berries. And on our campus, honeysuckle is in the containment stage. It's pretty bad on our campus. And this is the map of the cross-country trails. There's some spots over here and right here. And mainly, this trail right here is the most walked on trail. And actually, every single invasive species that we go over is on this trail because so many people walk that one specifically. The next one would be Japanese barberry. They're bushes with red berries and thorns all over them. They're very annoying to get rid of, as you can see Sean digging one up right here. And they outcompete others by preventing sunlight to plants, and they bring in a lot of ticks. They spread through the red berries, as you can see here. It's a kind of a blurry photo. And the berries actually have no nutrients, and it's eaten by birds. And when the birds eat it, they actually die. So that's not very good. And on our campus, Japanese barberry is in the eradication stage. There's only, I think, 2 bushes left on our campus. As you can see right here in the old growth forest. It's not that bad.
So our next invasive is Phragmites, or most commonly known, common reed. They are tall. They grow up to 6 feet tall, and they have feathery plumes, as you see in this picture. at the very top of them. They are very easily spread by wind because how high up they are, and they are one of the most affected by the boot cleaners because of their seeds being so small. They are dangerous because they tower over any other species that they are above, and they are on the eradication stage because they are only in
One location area.
only near the parking lot to the south of it. And our next one is multiflora rose. They're woody shrubs. They have red berries and they can grow up to 15 feet. They grow 5 white petaled flowers in August from their red berries. And they also reproduce from the seeds in their berries. And they can also dig into the ground and spread new roots and form new plants that way. They are in long-term management stage because they are throughout all of campus. They are very dense. And as you can see, they are on that trail like Logan said earlier, and there's some.
So next on the invasive list is Russian olive. Russian olive are trees or shrubs that have many small cherry-like fruits. They spread by seeds and most commonly birds and have nasty thorns. They also have fragrant blossoms that spread rapidly. And on our campus, they're in the eradication stage since there are so few in number. As you can see here on the cross-country trails, we have 2 main instances of Russian olive. And next is buckthorn.
So buckthorn is a deciduous shrub or tree that can grow up to 25 feet in height. Their bark is dark gray, as you can see here, and their inner bark is orange, which is interesting. And buckthorn is spread by birds, like a lot of them, and other wildlife. And they're not good because they lessen biodiversity, keep sunlight away from other plants because they're so dense. And on our campus, it's in the eradication stage. There's not that many instances of buckthorn, if I'm not mistaken. There's one. Yeah, there's just one on the main trail.
So Japanese knotweed is our next one. They are a perennial plant, which means all year round, and with alternate leaves and hollow stems, as you can see in that picture. And they also have white flowers in August. They are dense. They cover other plants just like Phragmites, and they can also grow up to 6 feet tall. The little pieces that you can rip off of these can form new plants when they reach into the ground too. And on our campus, they are also in the eradication stage. As you can see near the disc golf course.
So next on our list and last on our list is garlic mustard. Garlic mustard is a biennial or winter annual herb normally 2 to 3 feet tall. They can go up to 6 feet tall with kidney-shaped leaves as shown in the picture. Their roots dig deep down so it can help others by serving droughts. And they are one of the most effective invasive species when using boot cleaners due to their seeds being extremely small and easily catching into your boots. On our campus, they are on the long-term management phase of the invasion curve since there is just so much of it. So as you can see, here is some in the cross-country trail. They're also in the old growth forest, as well as the golf course. Here's another picture of every single invasive on campus that we have. And next, what's the solution?
So what is the possible solution? So the boot cleaner will help scrape the seeds off of your boots. And then the kiosk will hopefully capture your attention by having a question and stuff. And they also give information about the trails that you will walk. So the effectiveness. There was a test in 2006 by Southern Illinois where they put 50 boot brush stations around, and they resulted into 39 invasive species being found. Some of the ones that they found were garlic mustard, that we have a lot of, and stilt grass. They realized that maintenance of the brushes were a must because they end up getting clogged with dirt. And if unkept, the invasives will end up growing, and which would cause less use of the boot cleaners. And you also have to clean the signage because that also gets dirty, not just the boot brush. And you would hopefully change the boot brush every once a year because the bristles also get worn down and clogged up. So the garlic mustard experiment. So, well, we tried to recreate that experiment, but the soil that we got did not grow anything. But the place where we've been scraping our boots off all year round has grown garlic mustard, one of the ones that were found in the other experiment.
So some of the challenges of getting people to use boot cleaners is usually a case of bad communication. They may not know the danger of invasive species, or they may not know where the boot cleaners are in general. or have it be a case of apathy where they just don't care enough to try it. So some of the boot cleaner designs, as you can see here, some likes is obviously like information telling you about the invasive species, a nice handlebar, and a big boot brush down here so you can get a lot of the invasive species off and get your boots clean, and having a bench to make it a bit more comfortable. And a dislike is that there's no collection tray under the boot brush, which means a lot of invasive species will go into the dirt and go around it, just like the test said, and that's obviously not good. And to continue that, there's a gravel seed catcher down here, and that's good to take the invasive species, put in the gravel, and it's easy to remove. The kiosks are very organized, as you can see, very kept nicely. And the dislikes for this one, there's nothing catching the seeds here, so like a case before, they don't just spread everywhere, which is not good.
So the kiosk designs that we want to have in ours is a question, like, are your boots brushed? Or give invasive species the brush off, like the quote. We also want to let them know that if they do not brush their boots, that they can also spread the invasive species into their houses, which you definitely do not want, so brush boots. The trail could also be ruined if they do not clean their boots. Also, clean your boots before and after you go into the trails. And we also want to include a QR code in our own design, which will bring you to a huge slideshow, which has more information about some more invasives that we have on campus.
So what are some seeds on our campus that we're gonna wanna watch out for? On the left, we have garlic mustard, and as you can tell, their seeds are extremely small, and they can easily attach to boots. And phragmites on the right easily disperse through wind, and they can easily be picked up by boots because of their small size as well. So where are some locations for our boot cleaners? So we have some locations as shown in the cyan, and we chose the location due to mass traffic entering into these locations.
So in conclusion, going forward, we've asked Michelle to contact some people to get grant money to build these future kiosks on our campus. And another thing is to look at our own property potentially and look for invasive species so we could try to get rid of them and have people get boot cleaners for their own homes to prevent the spread of invasive species. What we personally have learned is that there are a lot of different types of various invasive species that we didn't even know about before this. And we've also learned how there's a lot of effectiveness for boot cleaners and the impact of human involvement with the environment, which is not intentional, but it's still very impactful. There's a lot of citations. We use a lot of different sites to get information on the invasive species, boot cleaners, the test, which was shown by Cameron, and some other things too. And these are some blurry photos that we have. I think this is the first day we went outside to look for invasive species. And these are the, what do you call it?
Wigwams.
The wigwams.
That our whole class basically made.
And the cross country team as well, I believe.
Yeah.
So any questions?
Charlie, I have
I
a
was just
question.
gonna ask, so what about the cross-country teams coming from other schools as well?
That is true. Yeah, so because of in the cross-country trails specifically, they would also have to read the kiosk potentially and just to know to clean their shoes off when they're done with the when they're done running. So that would just have to be a case of letting them know that their impact would be on there and they would have to use the boot cleaners. Who would tell them? I'm not sure, but that's
Good kiosk.
a good kiosk, exactly. Good answer.
Good question.
Are there any groups that work on removing the current species from campus?
Hold on to the next presentation.
Yeah.
They've got ideas.
They have a whole presentation on garlic mustard because it's so bad, but yeah. We personally, we removed a bit of Japanese barberry, but in terms of like groups that did it, there would be, yeah, them back there, he's waving, yeah. So that was garlic mustard, he did a whole project on that.
Any other questions?
Oh, one more.
Can any of these invasive species be eaten? Like human consumption? Like
Some of them are edible, but I definitely wouldn't recommend it. Like Japanese barberry was poisonous and a lot of them taste pretty bad. I think maybe Sean ate
Many nasty
berry.
thorns as well.
And yeah, a lot of thorns. So you technically could eat the berries, but I would not recommend doing that, so.
Yes. Go.
Just don't, yeah. They're removed for a reason.
Short answer,
Don't do it.
Well, I gotta feed you, Karen.
Yeah, so I would just say that with this many kids in the class, I have learned through the years that the number one spread of invasives on our campus is us. Right, it is, because we took a march down 3 or 4 years ago down a spot that I know no one goes to. And now today we've got this linear line of Phragmites going right by it. So we try to be pretty diligent, and it's one of the things I'll be talking to the board about, looking for grant money for, is building an actual boot cleaning station for the environmental class. And perhaps the cross-country teams that come in, because it is a genuine concern that we're gonna be impacting our awesome campus. So,
Maintenance wise. You have a question in chat.
And you got cut off. I think somebody online has.
go ahead, Dan, ask your question. Good to see you, by the way.
The trouble with that is gonna be with the maintenance aspect, because of the trails and because of this golf course. I worked maintenance at the school a number of years, the lawnmowers, mowing of the trails and such, the upkeep of it. That brings more in because we had infiltration into the football field a number of years ago that Bill had to take care of. So the grasses ended up with orchard grass on the football field, on the varsity football field, that we had to basically totally eliminate and restart.
Yeah.
So.
More cases of unintentional human involvement, yeah, it's rough.
Great job, you guys. All right, so our next group is about, well, Jack in the Hedge. This is Cole and Colby.
Hello, I'm Cole Bingham and this is Colby Wagner. Our presentation on Jack in the Hedge, also known as garlic mustard. And our goals for this project were to learn the history of the invasion of garlic mustard, locate garlic mustard on our campus, attempt to measure the amount that's actually there, remove the plants and seeds best as possible, and educate the general public on garlic mustard. Okay, so garlic mustard in New York started down here in Long Island. And then if you look closely, it does go up the interstates, and that's a majority of where it is. It was first found in 1868. It was originally brought from Europe, parts of Asia. We believe it was brought here because for, like the name, an herb to eat. That answers another question from earlier. Can you eat it? Yeah. It doesn't smell good, but you can eat it. And it also possibly could have got spread from the boats onto the boots, and then people walked around on it.
Right, garlic mustard is an herbaceous biennial. Herbaceous means it has no wood to it. It's not like a shrub or tree. It's just root and plant. And biennial means a 2-year cycle. And I will be going over the year 1 and year 2 respectively. And they, like my partner said, it smells like garlic or onion when crushed up. That's a rough. I mean, it roughly smells like it. I was the smeller and it did not smell good. So, yeah. And the leaves grow in rosettes that hug the ground. You can see it right there. It pops out and it's all against the ground. So it's not really going up in the year 1. And they're dark purple to green, kidney shaped leaves. We didn't see any purple ones, but we did see the kidney shape. That was our main identifier. And well, one of our main identifiers, and you can kind of see it there, how it's shaped like a kidney. And our main identifier was the S-shaped root. And I mean, you pull it out and you'll see it. So by that point, you know, it's already too far gone, whatever you pulled out, if it is or isn't, but you can start to understand what the garlic mustard looks like the more you see this, and then looking at the rest. In year 2, grow to 1 to 4 feet tall. As you can see with that lady there, that is probably 3 feet tall. And they, I mean, for us, they were all already, all the leaves were gone. So getting pictures of them were kind of difficult. So we didn't really get any that tall or any that we could see. The leaves are triangular and sharp tooth. As you can see, they're not really as round as year 1s. And they have white cross-shaped flowers, as you can see right there, and they develop seed pods. There's up to 16 seeds per pod, and there could be anywhere from 700 to 6,000 seeds, which makes them just spread really quick. And the invasiveness, they can grow so dense they'll kill off any competition. The seeds remain viable in the ground for up to 7 years, which also makes it tough. If you have 6,000 per plant and they're in the ground for 7 years, getting rid of them is very difficult. And the roots produce toxic chemicals that minimize growth of other plants. So they'll kill off soil fungi, which help plants nutrient gathering. And they'll prevent maple tree sapling growth, which will open up the forest floor more and will further spread the garlic mustard.
Okay, where is garlic mustard on the invasion curve? The last group talked about the invasion curve, so I'm not going to do as much, but it is up here in the long-term management. The main reason we want to manage it is to help our deep woods not, die.
Right, mapping garlic mustard invasion. Invasion line is the group before showed it, and the group before that also showed the area. We are just east of the school along this area right before the disc golf course. It was most likely brought in by foot traffic and mowing, and we took a picture here showing the trail down just to get the sense of the size of the invasion. And this was only in this small area where we really did our research. And that is right here. That is my friend Cole down there, just to show. I went all the way down there and you can see the parking lot and a bit of the school through the trees there. In the mapping process, we try to get a sense of the invasion density. We place these flags all by the year 2s because we weren't as familiar with the year 1s when we first started. And we placed it along there and just marked the perimeter with that, and that was our area. And then we took a meter square, put it around a dense patch of garlic mustard and pulled all those out and counted them just to see how much there was per meter. And that is our other partner, Evan, right there. And what we found was on both sides, it was further on the north side, it was most likely from the wind. Wind blows northwest, or no, yeah, northeast. And it was more concentrated again in the north because that was a less dense area when it came to tree cover. So we think the more sunlight just allowed them to grow and spread more. Oops. Good at that.
Okay, methods of eradication. This is the ideal method, is to pull it out of the ground as best as possible without spreading it around. So you want to just, you could grab it and lightly pull it up or use a shovel or trowel. And then after you get it out of the ground, you want to kind of scrape the dirt a little bit, trying to get some seeds off the ground since there are so many. And also, if you leave it there, you got to put it in a bag or burn it if you really want. But if you just leave it on the ground, it's going to spread. And every one, like we said earlier, could have up to 6,000 seeds. So if you pull one, properly dispose it, you could stop 6,000 more garlic mustard. But there's also another one for more big infestations of them, is just chemicals, herbicides to get rid of them. Even though it will kill the other plants around it, these already do it since how dense they are and how toxic they are in the soil. But since chemicals are one of the better options to use, we want to do an investigation on it. And that investigation is to, during the winter time, because they're green, as you see in the picture, right over here, they're still green, which means they're still photosynthesizing, which most plants are during the winter time. That's why trees lose their leaves and all that. And so we were wondering, is it better in the winter to do it? Because they will take in the Roundup or whatever herbicide you're using. And we're wondering if that'll only kill them and not the other plants around. Okay, our conclusion. Garlic mustard is a legitimate threat to our deep woods. We will have to manage it sooner or later, or we will lose the woods. Boot brushes, as the group before us, will significantly help awareness for them. And, but unlikely unless we could get massive child labor to start pulling it. I mean, the elementary school kids and middle schoolers, not actual child labor. If we can convince them it's fun, they'll do it. And it's free. And future work is to investigate the idea of spraying during the winter time to only kill plants.
All right. What did we learn? Garlic mustard's everywhere. That's all garlic mustard right there. It wasn't that bad for us, but it was still everywhere. It was, right in the cracks of the school. It was up in the disc golf course. It was in the cross country course. It's everywhere. Pulling it is very long and tedious. You have to really dig in to get to the bottom because the roots really dig down into the soil. And that is strawberry. It looks a lot like garlic mustard, as we found out. We probably spent like a week pulling out wild strawberry. And so it definitely didn't help. So we should have looked for that. That was definitely our major blunder there, because they look a little similar. And that's the S-shaped root right there. Right. Those are our sources.
Questions?
Okay, thank you for your presentation. My only real big question is the use of a, pesticide or herbicide to get rid of it, because I'm not sure if that's really helpful to the environment at all.
That's why we were looking into the investigation of during the winter while they're still alive and nothing is, to see if that's a better method than pulling it.
Okay. Would vinegar and some dish detergent work? Because there are other ways to get rid of unwanted plants.
I think, Linda, we lost audio. Put it in your chat.
Okay, I will try to, if I can figure out how to do it. Okay. I don't know.
Okay. Yeah, okay. I'll tell the online post.
Okay, I don't know what to do.
For those of you online, we lost the audio. They're working on it. All right. All right. Good. Can you log back into Zoom? I would recommend that. I think I signed up until 9. Okay, I don't see you. I do. Okay.
Senior at Livonia High School. I'm Esther Slocum, I'm also a senior at Livonia High School, and our project is the tree tapping project. So the main goal of our project is to educate people on the process of tapping trees. So things like why maple trees, which maple trees, how to actually tap the trees, and if this could be profitable on our campus. So what inspired us, our class was given an opportunity to have a guest speaker come in. He's right over there with the class. His name is Bryce June. He's a forester for the DEC. And during our time together, we talked about like many different topics, but something that stood out to me and Esther was the potential profit of tapping trees here on campus. So that's kind of like what inspired us to do this project. So what trees can be tapped? All trees produce sap, but maple trees have a concentration of sugar. So we chose to do a project on sugar maple trees because they have one of the highest sugar contents. You can see here that darker syrup would come from a silver maple. It gets darker because they have a lower sugar content, so it takes longer for the sap to boil down into syrup and it almost caramelizes. And would be from a sugar maple, and it's lighter because it doesn't take as long because of their higher sugar content.
So how many taps you can put in a tree? This can come with experience, but if you're kind of new to it, something you can follow is if you have a tree that is 10 to 20 inches in diameter, you can put 1 tap in. If you have a tree that's 20 to 25 inches in diameter, you can put up to 2 taps. And if you have a tree that's more than 25 inches, you can put up to 3. But no matter your tree size, you shouldn't have more than 3 taps. It can actually cause more harm to the tree.
So does tapping hurt the tree? Tapping does create a wound, which you can see here. But in about 2 years, the tree will heal, and you can see that wound up there is a healed wound. This would be when you take your tap out at the end of the season, that's how it would look.
So this placement of taps matter when tapping trees. If you're doing this as like a 1-year kind of experiment to like see how it is, you can actually put a tap underneath like a large branch or limb because sap runs up the trees to all the tree branches to provide energy to all the leaves. Therefore, there is more sap for large tree branches. But when you're tapping, make sure you avoid the same spot that you tapped the previous season until the new wood has healed the previous tap hole.
So Dr. Randall came to our class. Dr. Randall is a retired professor at botany, and he also owns his own sugaring company. And he taught us that every year, just so you move your tap consistently, you go 4 inches to the left and 3 inches up.
So this is a tree cookie actually from Dr. Randall. It's about 103 years old. Our next group will get more into the tree cookies, but basically this is like a slab cut from a sugar maple tree. So those like scars all throughout the cookie here are actually tapping scars. And there are good and bad examples. But right here is an example of a bad scar. As you can see, the 2 taps are like right next to each other. So that means they were like tapped like in the same year. So that's not good for the tree. And then this area here was actually an example of a good tapping because as you can see, they tapped one season and then they waited about 15 to 20 years before retapping. So it actually gave time for that initial tap to heal. So that's just like an example of a good tap.
So what time of year is best for tapping? Generally, mid-February to mid-March is when you can get freezing temperatures at night, so below 20 degrees, and then warmer temperatures in the day around 40 degrees, the sap can thaw and run.
So materials needed to tap trees. First you'll need taps, they're also called spiles. Esther actually has a couple that you can pass around. You'll then need buckets or any other sturdy container to collect the sap. You'll then need lids for the buckets to help prevent like any larger objects like leaves or branches from getting into the sap. You'll then need hooks to put in the spile to hold your bucket. But the taps that Esther is passing around now, those actually have built-in hooks, so they can come in or you have to attach them. You'll then need a drill to drill into a tree about 2 inches to actually place the spile. And they have these tree saber drill bits that actually make it a cleaner cut when drilling into the tree. It also helps prevent you from going further in than 2 inches, so it just causes less harm to the tree. And you'll finally just need a hammer to actually set the spile into place.
So how to tap a tree? So like Katie said, you drill a hole no more than 2 inches into the trunk of the tree. And a good rule is to angle your drill upwards a little bit. This helps the tree heal faster once you take the tap out because you won't have water pooling in like a downward tap. And then you attach a hook to the spile. You place the spile into the tree. Then, like Katie said, use a hammer to set the spile into place. And then you finally would set the bucket on the hook. We showed like professional maple syrup buckets, but you can use any food grade jug, like a milk carton or a water gallon.
So the big question we like asked ourselves during this whole project was how much sap we could actually produce on Livonia's campus.
So this is just a picture of our campus. That's our school up there. And in the southeast quadrant, we have woods, which are about 4.4 acres. And in those acres, we have about 200 sugar maples.
So the steps we took, we first had to identify the maple trees. And by doing this, we would look at the bark and structure of each tree. We would then measure the diameter at breast height, which is also known as DBH. We would then tag a number each tree. And to make it easier, we tagged each tree on the west side for easy IDs when we're walking up on the trail. We'll be able to see like all our tags.
So this is just a picture of some of the trees that we tagged. You can see they're all on the west side, like you said. This just made it easier when we went back out to take pictures and measure just to find them.
So this is me and Esther doing some of our data collecting. As you can see here, I'm using this DBH measuring tape. It's really nice because one end actually has a hook, so it's easier to wrap around the tree so you can get a proper DBH.
And this is a spreadsheet that we put all of our data into. So on the left there, we have our tree number. In the middle, we have the DBH of the tree. And then on the right side, we have how many taps we would put in that tree. So this tree here is tree number 18. You can see that at the very bottom. That DBH is 28 inches. So that's a tree that we could put 3 taps in without damaging it.
So to kind of wrap it up, how much sap we would actually expect on Livonia's campus. So we estimate in that 4.4 acres, we would get roughly about 300 taps. And each tap would bring us roughly about like 10 gallons. So that would get us about 3,000 gallons of sap. And 40 gallons of sap actually makes 1 gallon of syrup. So at the end of it, we would get about 75 gallons of actual maple syrup. So what we learned here, so this is a picture actually of Dr. Randall. He helped us a lot during our project. He has years and years of experience doing maple sugaring. He actually has his own business, but he actually helped us a lot because he answered a lot of our questions we had. So other things we learned is that we first learned how to actually identify sugar maples. We then figured out how profitable it could be on our campus. And then we also learned how to make our size easy to understand because there may be people in the audience that might not know anything about tree tapping. So we wanted to make sure that we kind of started from the beginning so it'd be easier for you guys to understand. And another thing we learned is how much work actually goes into the sugaring process. And this is just the beginning of it that we're describing. There's still way more that goes into it with the whole boiling and actually making it, but that's something we learned.
So our conclusion and our future plans, we concluded that we do have enough trees and sugar maples on our property to be profitable on Livonia's campus. And the trees are in a good location. Most of them are on a hill, so gravity can help the sap run easier. And based on an estimation of the general cost per gallon of sugar maple syrup in New York is about $35 to $40 per gallon. So we could estimate that our total revenue would be between $2,800 to $4,500. And our future plans would be to get grant money to help fund the building of a sugar shack here on campus and to start a tree tapping program at Livonia. Thank you for listening. Yeah, this is just a little demonstration of what it would look like if you tapped a tree. My dad made this for us.
Thanks, Dad. Where's Dad? Thank you. Any questions? There's a lot to unfold there.
Are you thinking more of a pipeline system off the hill or?
Yeah, that would probably be more efficient than just
I don't know about that, but maybe. Yes.
Depending on the season, you can bump your numbers up quite a bit. I have 2 trees at my house. I generally get 10 gallons of sap off a day.
Really?
Each.
Wow.
So depending on the season, if it's a good season, a good run, you get much more. And the price, your price is a little low there for your sales. Yeah. I'll buy from you, really.
All right, thank you. We're ready for the next one, everyone. We're just gonna keep on rolling. Take it away, gentlemen.
Hi, guys. This is Tommy Kesa, senior at Livonia High School.
And this is Charlie Roberts, junior at Livonia. And today we're going to be talking about our tree cookie project that we did this year. And the first question you may be asking yourself is, what is a tree cookie? So a tree cookie is a section of tree about 4 to 3 inches in diameter or width. It is used to illustrate the life growth of a tree. And it also can be used to interpret the history of the climate around it. We had multiple goals for the city. Our first goal is to study the tree anatomy, which we learned a lot about trees and found out that they're a lot more complex than we thought. We wanted to compare different types of trees at our school, so we found that it's a very diverse place in Livonia. And we also wanted to reconstruct our forest climate.
So first, let's get into tree anatomy. Trees have different parts that each have different functions in order for the tree to survive. First up, we have the bark right here, the cambium, the red layer right here, the xylem, otherwise known as the rings, right here, and the pith, the center. So first up, we have the bark, which has 3 main components.
So the bark is the first thing you see on a tree. It's what the naked eye sees. And so the outermost part is the cork, which you guys might be familiar with. It provides protection for the trees from weather and animals and even humans ourselves. The next layer is the phloem layer. It passes the food to the tree and provides growth for the tree. And finally, we have the cambium. The cambium produces the new cells, which allows the tree to grow in width and size.
And this is, you guys may know what the emerald ash borer is. That's what it eats, the cambium. So next up, we have the xylem, otherwise known as the rings. The xylem is in the xylem, there's tiny holes that transport nutrients and water from the base of the tree up to the branches and leaves. And the xylem is made up of 2 different parts, sapwood, the light stuff right here, and heartwood. Sapwood is the living part of the xylem. That's where the holes are that transport the nutrients and water from the top to the bottom. And then the heartwood is the sapwood that eventually dies, and the heartwood is just a structural part of the tree. It's also used for protection. So the pith is the oldest part of the tree. Okay, there you go. It also provides support. So what tree rings can tell us? Tree rings allow us to determine the age of the tree. This is exactly 1 year of a tree right here, from the start of the light to the end of the dark. Tree rings are made up of 2 different parts. Springwood, the light part, which is the rapid growth in the spring, and then summerwood, which is the dark part, which is what the tree uses to prepare for the winter and protects it.
So the difference in color of the tree rings is only visible here in temperate climates in comparison to people down in the equator where trees, you might not see the difference in colors because year round it's warm. So dendrochronology, dendro meaning the tree, chronology meaning the study of time, it shows us the life. So if you were to count back from the pith, it would show you the years that the tree was formed from. So you can tell the impacts of the environment from fires, competition, and human taps, like the group that just was before us. So here you can see a fire scar on a tree, and this is from either a forest fire or say like you were to have a campfire next to a tree, you would also see the scarring at the base of it. Competition here is shown at the bottom. So at the bottom of that tree, there must have been a tree next to it that was competing for sunlight. So the growth isn't as much as up top where the tree might have had more sunlight.
Also known as tension wood on the bottom.
And finally, we have human impacts such as taps. So taps is like from the maple syrup that we talked about earlier. And like I said before, you
see the past growing conditions in a tree. So if it was a dry season or a wet season, which is what we have here. So there on the arrow that you can see there, that would be a wet year. And so it would get a lot of rain and more growth. Next, we would have a bad year, which would be a drought. As you can see, the ring is very small, but here in New York, we have an abundance of rain, so that typically isn't a problem here. Normally, it's the weather that is causing that. So a cold year, so say you had a lot of cold summer days, that would make the ring smaller in comparison to a warm summer that you have weather all year round. That's typically here where you see the bigger rings. So firstly, we're going to show you our cookies. So this first cookie here is our white oak. This was our favorite cookie. It was 60 years old, and it was from the blowover that a group preceding us are going to tell you about the blowover that happened here in June. So that was in the old growth forest of the school. Next, we have our ash tree, which the top here, you can see the emerald ash borer. If you guys are familiar, natives to Asia, came here in Michigan through a boat, and it kills most of the ash here around this area because it's very present now. And this was our oldest tree. And finally, we have our black walnut tree. There's nothing really special about this tree, except that it has the fire scar that you can see up there on the top right. And this tree was very young when it died. It ended up falling over. So our tree locations here, if you see there in the top left, that would be where our school would be. Down to the bottom right would be the cemetery on Shelley Road. You guys are familiar with that. Also, groups before us talked about the southeast quadrant, sorry. So this is old growth. So when we first walked in, that's where that fallen over white oak we talked about was, and that's where the first tree was. And then the ash and black walnut were right next to each other towards the property line down more south. So first we have our black walnut field photos. This again was a widowmaker, we call it. It is hung up from a tree. If it fell over, it's still hung up, so it's dangerous, so it had to come down. So this was it before we cut it down, and then this was it after Bill Vogt, which we talked about earlier. He was a big help for us, cut on all the trees. And so this was it after. Next, we have our ash field photos, which you can see Charlie there scraping to try to find the emerald ash borer, which we ended up finding on this tree. So that's why we chose it. It had to come down, it was dead, therefore making it dangerous. This was it after it was cut down. That's the cookie. Next, we have our white oak, our favorite. You can see here on our cookie that is around here somewhere, it has a lot of competition because of the trees around it, you can see it. So that's a very good indicator of the competition. And this was falling over from the wind event like we talked about, and then the cookies. So our process to start with, we had to find trees. So we found about 7 or 8 trees that we chose our final 3 from. This was an original hickory we wanted to use, but ended up it was just too difficult to handle. But that was it falling over, and you can see Bishel there trying to turn it over so we can see what we're looking at. Next, after we found the trees and cut them down, we had to sand them, and sanding them took a long time, probably took 5 or 6 days, give or take. So that's me and Charlie sanding them. Next, after sanding, we had to measure, and I wasn't there for this. Charlie did a lot of the measuring, which I heard was painful. Measuring with the naked eye with the ruler, you can tell it probably is the most accurate way of measuring, but that's all we had to work with, so that's what we did.
So now let's get into some characteristics of our tree cookies. First, we have the black walnut. Like Tommy said, it's our youngest tree cookie. It's only 51 years old. Something weird about it is that the summer wood, which I talked about earlier, used for protection, is there's very little amounts of it per year. That's not good. That's probably why this tree fell down early in its life. And then you can see the burn mark around 14 years ago. We don't know how it happens. It could be anything. Someone suggested that it could be some kids messing around, but that's not likely. So this is a graph showing the black walnut growth throughout its life. This is the trend we normally see with trees, the downward slope where it's rapid growth at the start of its life and then lower and lower as it goes on. That doesn't necessarily mean that its growth is getting less and less per year. As a tree gets bigger, the trunk gets bigger, so the tree has to push more material out around its circumference. So the amount of tree material that gets pushed out here could be the same here. It just has to push out more as it gets older. So next up, we have the ash. It's our oldest tree. It's 130 years old, and it was probably killed by the emerald ash borer. What the borer does is it attacks the cambium and it eats the cambium and then it poops it out into sawdust and creates these trails. So here's the graph for the ash. It's not what we normally see. It struggled early in its life in the late 1890s and early 1900s, and then it had good growth in the early 1900s, and then it struggled again. Right here, 2020 was when we think the emerald ash borer started affecting it because it's like a last attempt to survive, and then 2022 when it got cut down. So now the white oak, our favorite. I like to say how it's 62 years old, and then I love how it smells like salt and vinegar Pringles. So like Tommy said, the summer wood growth is larger than the spring wood. That's the dark. We don't know why. We asked Dr. Randall about it, and we stumped him too. So you can see here that there's competition on the left side. You can see the tension wood compared to the right. There's a lot better growth on this side because the white oak was right on the other side of the tree. And overall, this tree, before it got blown over, it had a good life. So here's the graph of the oak. It doesn't have that trend we see because it had really good growth as it got older. It's very steady. And around 1998 to 2000, it had very good growth, over 6 millimeters of length per year. So what we did was we compared the graphs of each tree, the white oak being yellow, ash red, and black walnut being blue. We looked for patterns of growth. We didn't really see many. The ash kind of stuck that life compared to the other two. The black walnut and ash, or not the ash, the black walnut and the white oak in the early part of their lives had similar patterns of growth right here, and right here also, but otherwise that's pretty much it. So what we learned, we don't know this lady, we just thought it would be a good addition. We learned a lot about science and tree anatomy in general. Due to the irregularities of our trees, we never found patterns like we were hoping. We were a little bit disappointed because otherwise in the start of growth for the white oak and black walnut, there wasn't much. And we realized, well, I realized measuring tree rings takes a lot of time. Tommy got sick that week. And we also realized trees are more complicated than we thought. There's a lot we could learn, a lot more we could learn.
So our future work. Maybe another group will take on this project, years to follow, but me graduating and Charlie being a senior next year and probably not taking his class, we're not going to be doing any more studying on this project. So, and we also learned that tree cookies you can continue to analyze them and find different growth patterns, and maybe other parts of the campus might have a different story, but that's something that we cannot tell. So here are our citations, and thanks for listening.
And the folks on Zoom, if you want to ask a question, you can hold the space bar down on your computer and ask the question.
And I think the tree cookies are outside for you guys to see.
They're right back here. We got to get one more moved over there. So on your way out, you all can kind of check out their handiwork. Rub your hand across the surface, feel how smooth that is. All right, lots of work there. By the way, do you know why the summer wood would be thicker on that the oak? Because most of the trees I look at when I cut them down, that summer wood is definitely narrower than the spring wood. And on that oak, it is hugely pronounced. Yeah.
Maybe it has something to do with it.
Yeah, cool. We're gonna look into that. That was really cool. Good job, you guys.
No questions, everything will
No, I saw it and I
The point that you want to stick, point things with? All right, everybody, here we go. We're live.
All right, hello, everyone. I'm Christopher Coyle, a senior here at Livonia High School.
I'm Tanner Gray, also senior here at Livonia High School.
And I'm Gavin Wilson, I'm a junior.
And today we will be presenting to you about the bewildering blowovers on Livonia High School's campus. So before we begin, just by a quick show of hands, who was aware of the June weather event that we had here this past spring? A lot of storm damage for sure, okay. So for those of you who are unaware, or for those of you who would like a refresher, to start off here, we had winds of excess speeds of over 100 miles an hour here in this northern region of Canisius Lake, and then going from west all the way to the east, all the way up to Bloomfield, I believe, stretching across the northern portion of Livingston County. Trees were blown down all over the place. Power lines were down. Thousands were without power. And we were really intrigued as a group just kind of to study maybe these trees, how they fall down and what kind of patterns we can analyze, historical patterns throughout history with trees and wind damage as a whole.
Yeah, so after seeing all this damage the storm caused, we want to do a little more research to figure out why these blowovers actually happen. So the first thing we learned was that blowovers tend to happen in the spring and summer months when they're covered with leaves. And the leaves actually catch wind and are pushed down by the strong force of that wind. And finally, we learned that trees with moist soil are more susceptible to being blown over due to the lack of support of the roots that they have. So after doing a little more research, we came up with some goals for our project that we wanted to accomplish. The first thing we wanted to do was find the blowers that we had on our campus. Then we wanted to map them. And then we wanted to measure them to figure out the similarities and differences between them. After that, we wanted to figure out past storm events using pillow orientation, which we're going to talk about later in the presentation.
Yeah, so we completed our first goal and we mapped the blowovers on our campus. This map's from a bird's eye view. The key for the map is over on the left over there. There's 3 colored dots. The red ones are black walnut trees. The yellow ones are silver maple trees. And the green one is a white oak tree. So on this map, our high school is right in the middle. The varsity soccer field is in the south. And up here is the disc golf and the cross-country trails. And then in the northwest corner is the fire hall up there. And by the fire hall is our first group. It's the black walnut trees. They're also right along Wilkins Creek. And then in the southeast quadrant is our silver maples. Those are by our wetlands here on campus. And we think that the silver maples and black walnuts, we think they fell down in large numbers because of the wet soil conditions around them. And lastly is our white oak, also in the southeast quadrant. And so what we did with these trees, we took some baseline measurements. The first measurement we took was the type of the tree, which is like the white oak, the silver maple, or the black walnut. We also took the tree height. So that's basically the distance from the root ball all the way up to the top of the tree. And we also took the circumference of breast height, which is the circumference 4.5 feet up from the tree. So you can see that in this image here. You can't see the full thing, but this is 4.5 feet up the tree, and that's just the circumference. And the last measurement we took was the geographical direction of the trunk fall, which is just what direction on the compass the tree is facing when it flew over.
Yes, so as you said earlier, we want to figure out the other past storm events that cause these blowovers to happen. And we're going to do that by looking at the pillows. So a pillow is actually this whole eroded root ball here that's filled with soil. And that creates a topographic high in the landscape. Once all that soil sets, that's along perpendicular to the direction of the tree fall. And under here, that is called a trough. And that is also elongated perpendicular to the tree fall. And that is a linear structural depression that forms when the tree is pulled up from the ground. So after looking further in these pillows and troughs, we then took some measurements to figure out the similarities and differences between them. So for the pillow, we measured the height of the pillow from the trunk side. Then we measured the thickness. Then we measured the length of the pillow, but we mainly focused on the direction of the elongated axis. And then for the troughs, we measured the length of the trough, the width of the trough, the depth, and then we mainly again focused on that direction of the elongated axis.
So in the future, these pillows and troughs will start to evolve from the current shapes that they look like in the images we've shown you before. And eventually you'll kind of need to look for a topographical high and a mound on the surface of the forest floor. And then you're gonna look for a depression on one side and a bit of a leveled out side on the other side. So when you want to like walk around the forest or your property and you want to try to find where a former tree had laid and see where that perpendicular angle in that bisection occurs, you need to kind of and position yourself almost along that elongated axis of the pillow. And then to find the trough, the original trough location takes a little bit of skill. Some guesswork is involved, but over time, I think we've grown to be able to predict roughly where these trees originally stood and which direction they fell from. But you need to kind of look for a depression on one side, and then the other side looks a little more level out in comparison. And roughly, most of the time, the tree would have been formerly on the side a little more leveled out. Sometimes you can be lucky and happen to find former pieces of bark and a decomposing tree that once laid there as well.
Yes, this is another map. We did that. We mapped the axes, and those are the lines there. And then the arrows are the blowovers. So like Chris said, they're perpendicular. The blowovers are perpendicular to the pillow axes. And that's important for mapping them on our campus and determining which wind direction blew them over.
Yes, we have some consistent southwesterly wind events that have occurred on our campus and all throughout the greater Western New York region as well, as we have prevailing westerly and southerly winds here. So depicted in this image on the left in the top corner here, this corresponds with the white oak that we studied on our measurement slide. And so you can see here with that right there, this is an image taken from the sky of the southeastern quadrant of our school's campus. And so that tree right there fell as a part of that June weather event that we talked about in the beginning of the slideshow. And that tree fell and ended up facing the easterly direction, so it was from a westerly wind. Additionally, we have two silver maples located here and here. Those two arrows correspond with those two trees as well. They were very similar in size, located in a very wet soil type. And then both of them also fell in the same weather event as that white oak. And then additionally, we had another silver maple that is corresponding with this arrow right here. And that's a little bit of an oddball. It's facing slightly towards the facing slightly towards the northwest, but is from an easterly wind, which is a little bit odd considering we normally have southwesterly winds. But that tree fell roughly in the 2018, 2017 range, give or take a few years, we assume, based on Mr. Sheldon's expertise of the area. But as you can see, it's much more eroded in terms of the roof ball structure comparison to these newer falls, but once again, fell in a very moist soil type area. And then additionally, depicted in this image, it's not necessarily a tree that completely fell over, but it just goes to show some of the wind damage that has been done in this area. And we think that this tree trunk that has been chopped off in half right there may have been from that June weather event as well. So corresponding with these images that we showed you before are all the different trees graphed on this table. So we have, starting from left to right, the white oak, the older silver maple here, and then the younger two right there. So as you can see, the younger two silver maples are very similar in characteristics. They have the exact same DBH, I believe. And so just for context, the DBH is the diameter at breast height. So earlier, Tanner, again, one of you explained what the CBH is, so the circumference at breast height. And so we took that measurement and then divided it by pi to get your DBH diameter at breast height, so 4.5 feet off the ground. Roughly how wide are these tree trunks? And then you have the heights here for all four trees, starting with that white oak, very large tree, fell down in some strong soil as well. So that was very confusing as to why that might have fallen down. But I mean, if you have 100-mile-an-hour winds blowing through, there's not much that can really stand through that. And then also you can know with all four, there's some consistencies with the proportion between the DBH and the height. Relatively speaking, most of them follow a similar proportion in that regard.
Yeah, so this is Tornado Alley, and this is our group of black walnut trees located next to Wilkins Creek. This is actually what we call a trash tree because that was located at an old dump site we had on our campus. And that was by far the biggest blowover we found. And then this tree was next to Wilkins Creek, actually really close. You almost see here is a creek. And then our last tree here, that was also next to Wilkins Creek. And again, these trees were found in a moist soil area. That's why we think they fell over through that Storm event. So these storm events prompted us to find more wind directions on our campus. So we were looking for these past blowovers on campus. So these are a little different. They don't have currently like a active root ball. So we were looking for these elongated pillows that are like more decomposed in the ground and like more subtle. And then some of them had the trees still perpendicular to them, and that was a big indicator for us. So these are the pillows on there, and those are the blowovers perpendicular. And then this is a color-coded one, and these are what we think are like the same wind events, or could possibly be the same wind events based off the direction. So like you can see like the yellow ones, those are the current ones that we showed earlier. We know that those were from the June storm event. And then some of the ones like the greens, those are kind of going the same way, like southwest to northeast from the pillow axis. And the red group, those are kind of running east to west. And same with the blue, those are also similar directions, and those are running from the north to the south.
So now some of you may be wondering, what can you do with this new knowledge we presented with you today? So one of the big things you can do is look out on the forest floor and see historically where trees have fallen, note certain patterns with wind directions, etc. You can additionally analyze blowovers and notice the different ecosystems that develop inside of the pillow of these former trees and the trough. So this is something we didn't exactly elaborate on in our project, but in future research that can be done by classes here at our school, something they could go in and do more analyzation and documentation on is the ecosystems that are created inside the water that pools up inside the base of these troughs. And then additionally, another good piece of knowledge to know is where are the prevailing winds and how might that affect your property. If you happen to have a large tree that is on the western side of your home and your home is on the east of it, the tree happens to have a westerly storm that comes down and blows the tree on top of your home, you'd be in rough shape, and that might be some good information to know in the future to see what trees are susceptible to falling on top of your house. But otherwise, thank you all for watching our presentation. We appreciate everyone's support for being here today.
Question? How did you determine which trees had blown over in that specific event?
So we had kind of had prior knowledge of which trees had already been blown over, such as that silver maple, but so those ones were all recent due to Mr. Sheldon's knowledge, and he was able to kind of tell us which ones had fallen over recently. And you can kind of look at the root ball and roughly see how much of that is still standing to kind of get a rough estimate as to time.
So it's possible that they didn't fall in that storm?
Due to the fact that we weren't studying the area as much as we are now before the storm, we wouldn't know with exact specificity, but I believe Mr. Sheldon would know for sure.
Yeah, I think those are, unless something happened while I was gone in July, those trees came down at the same time. Silver maples. Any other questions? Okay, two more to go, everybody. I want to get one. Well, no, suck it up and sit down. Leave that for the next one.
What?
28 August. It's really. Well, you're good. Okay, Wilkins Wildlife Trail Study. Hey guys.
Hello everyone, I'm Connor Benitez. I'm Matt Bean. And today we'll be presenting our Wilkins Creek Wildlife Baseline Study. So first, talk about why it's baseline study. So we're trying to figure out what our animals are in the area before the box garage is placed. So a group in the future years can look and compare their results and figure out what is there post the bus garage and compare how the bus garage has affected the area. So if you guys don't know, this is the concept image of our new bus garage that will come to our Livonia campus. One important thing is the fueling station here on the left, and then we're gonna have a bus washer on the right.
So let's go more in depth on why we need a new bus garage. The main reason we need it is currently the current bus garage is 5.1 miles away from our campus. And then that just creates extra wear and tear on the tires, around 80,000 extra miles on each vehicle. And then these are just some of the more benefits that will be gained from the new bus garage. So, how's the new bus garage going? The blue area is where the bus garage is intended to go as of now. It's currently a 3-acre early sessional field south of the Livonia Fire Hall and west of Wilkes Creek and our high school. And currently, we decided to split the bus garage area into 4 different habitats. White being a black locust stand of trees, green being our early sessional field, and then our south gully in orange and our north gully in blue. Let's go more in depth on each location. So our early sessional field is where the actual bus garage will be. Currently, it's our flattest area habitat in the area, and it's just a variety of shrubbery as of now. We got our black locust stand of trees, which is pretty much right in the middle of our bus garage area. And again, that's just a group of trees, just right in the middle. So we want to see like what's moving in throughout that area. Next, so as you can see, the right side is where Wilkins Creek is. It's the right of where the bus garage is going. And you can see that there's 2 distinct different canopies, with the blue being our north side and orange being our south side. So we split those areas in 2 to see the differences in wildlife there. So our south gully is a underdeveloped forest compared to our north, and it's younger growth and has an open forest floor with little canopy. Again, you can see the difference in canopy with the top being much more covered and little canopy on the bottom. So our north gully, again, is the oldest growth forest on our bus garage habitats, and it just has a large canopy. So our research question. So our main goal is to find the impact that the bus garage will have on the wildlife living in that area. And some of our goals are to document the habitats and wildlife that will be impacted, try to figure out some moving patterns of the wildlife, and then also try our best to predict the animal response. So this is just a picture of our trail camera arsenal. We had 4 trail cameras they were using, provided by Matt. And then, so we try to move these cameras around. We keep them in a spot for a few weeks at a time and then try to move them around to get the best coverage of our habitats as possible. So our camera locations. So these are the camera locations that we chose to do. Try to put them in a wide variety of our habitats. And we tried to put these cameras in areas of prominent wildlife moving through, so such as buck rubs, fenned animals, or tracks. So our first location is the thicket between the bus garage area and Wilkins Creek. And our main goal was to see what small game was traveling to and from the Wilkins Creek towards the bus garage area. And for reference, the white arrows are going to be showing which direction the cameras were actually facing. So our first location, our main thing was we found these fox. We aren't necessarily sure if they are the same fox or different fox, but these 2 guys popped up multiple times on this camera. Our next location was in our black locust stand of trees, again in the middle of the bus garage area, and it is facing towards the south. And our location 2 findings were actually a lot. So you see on the bottom, we got a fox there. On the left here, we have a bedded doe that actually sat on our camera for multiple hours, just keeping all the storage from our car. And then top right is a possum we found.
Okay, so our spot 3 we placed to the west of where the bus garage is going to be placed and along Wilkins Creek. And the wildlife we found there, we found a group of does and there was multiple fox moving through there. Our 4th location we placed in our north gully, which is our oldest growth forest, closest to the bus garage. What we found there was the same group of does and fox. We weren't sure if they're the same fox or not. Our 5th location we placed in our south gully, which is our youngest growth forest. And we got the same group of does and fox. There you go. So now I'm gonna go more in depth into the animals we saw. We had red fox, which prefer areas that are rich in vegetation. They are considered very good hunters. And we found them on all trail camera locations. Our rabbit, they prefer short grassy areas. And they are herbivores that are most active at night, which you can see on our pictures. That's what we got them. Our whitetail deer, whitetail can be found anywhere. And we found them everywhere. And we found, hang on. We had a doe that we think had a little pieball on her. She had white going up her legs, which we thought that was cool. Coyote, we only have one video of a coyote early on in our study when we had a trail camera at our wetlands. We moved that about a weekend. And coyotes, 90% of their diet consists of small mammals. We only got one video of a possum right in the black locust stand in the middle of where the bus driver is going. Possums require a nearby water source like Wilkins Creek, and they are omnivores, which means they will eat just about anything in their environment. We got a picture of, we think is the same chunky raccoon. And raccoons are usually nocturnal, which is when we only got pictures of them. And they're also omnivores. What we predict the animals will do, the fox will move into the gully and south into our ditch section of our Wilkins Creek. The rabbits will move into the gully and also down to the south section. Our white-tailed deer we predict will not be affected, and they will just simply avoid the bus garage. And our possum will move south or west into the gully. So later on in our study, we placed 3 trail cameras in our south forest at the ditch section of Wilkins Creek. We basically just wanted to see what animals were present there and look for an area that possibly could be used for the animals that were living up in the north to move down to. These are some of the images we got. We got fox, rabbit, and then that's where we got our first buck and our raccoon. What we conclude is that the denned animals will have to move like our prey, and our predators will follow them. And then we predict that they're gonna move because of the noise and 24/7 light pollution. And we predict the animals will start moving south into the ditch section of Wilkins Creek.
Questions? Any questions? Good job, you guys. All right, and our last presentation of the night, everybody.
You got 80%.
I didn't get 20 class.
Working magic, kid.
All right.
Okay, here we go.
Hi, my name is Kaylee Hasford, and I'm a junior at Livonia High School, and I'm going to be focusing on Wilkins Creek. So my project is on water quality in Wilkins Creek, and there's a couple different ways to go about getting water quality. You can either go down to the creek and get samples and do tests, or you can look at the creatures who are living in the creek, which is what I'm going to be doing, specifically macroinvertebrates. So benthic macroinvertebrates. Benthic meaning bottom dwelling, macro, big enough for the eye to see, and invertebrates without a backbone. So this is the basic life cycle of a macroinvertebrate. A lot of you guys will probably recognize them. And the adult stages, well, I'm going to be looking at them in the nymph stage, actually living in the creek.
And so here are the most common macroinvertebrates that we have in our creek, with stonefly and crane and caddisfly being the most important ones. And those are them in the adult stages. Well, I'm going to be looking at them in the nymph stages, which look more like that. So macroinvertebrates are split into 3 different groups or tiers. Group 1 being very sensitive to pollution, Group 2 sensitive to pollution, and Group 3 being tolerant to pollution. And so as you guys can see, a lot of the macroinvertebrates that we have in our creek are in groups 1 and 2, which means that we have really high quality water in our creek because they're so sensitive to pollution, and we have them in our water, meaning we have very high quality water. So macroinvertebrates are really important to stream health because, as a lot of you will probably know, that if you take one aspect out of a food web, the whole ecosystem kind of falls apart. And so they're really important in maintaining the balance. And it all starts with leaf packs, which are just groups of leaves that get stuck in the creek, and they form these little groups, which the shredders will shred and send organic matter down to the collectors and other macroinvertebrates. Another really important thing that macroinvertebrates can do for the stream health is prevent erosion. And so that's really important because, oops, my bad. And that's important because we have, Wilkins Creek is a very heavy sediment distributor, which is really cool. And so erosion was a big question that we had. And so it all kind of started when we went down to the creek and we saw these clumps of rocks, which you can kind of see right there and up here. They were just groups of gravel, which were attached to the larger stones in the creek. And so we thought that they could possibly be net spinning caddisfly, which was really cool. And so what net spinning caddisfly are these macroinvertebrates that spin these intricate webs that kind of look like spider webs, and they bind gravel together and hold it together, which can help stabilize the creek bottom, which, like I mentioned before, is really helpful because Wilkins Creek is a very heavy sediment distributor to Canisius Lake. And so that was a big question and an important factor that we wanted to look into. So in order to see if we had these net spinning caddisfly in our creek, we deployed what are called rock packs. And so rock packs are just these mesh bags full of small pieces of gravel and stone from Wilkins Creek. And we put them in a location in the creek where there's deep enough water and a decent amount of stream flow. And then you leave them for a couple of weeks and you take them out and see what you find. And so I deployed 6 rock packs at these locations. And the reason we chose these locations were because they had the highest water levels, which we had very low water levels this year. And so it's really hard to find locations that had deep water and a good amount of flowing water over top. And so here are my 5 rock packs, and I did have 6 locations, but then one day we got a very heavy storm and we lost number 2. And so we have no idea where that one is. But as you can see in number 1 here, it's kind of hard to see, but it's in pretty deep water with a decent amount of flowing water over top of it. And so after we did get that storm, it turned those locations into really good spots for our rock packs. So what did we find? Not net spinning caddisfly. We don't know if it was because of the low water levels that we had, or if we even have net spinning caddisfly in our creek. And so it was really hard to want to move forward with that project, not knowing if we even had them or if this was a good research opportunity. And so that got me thinking about stonefly. And so as you can see right here, in about 10 minutes and looking in one of our rock packs, I found 10 stonefly very quickly, very easy to find. And so we knew that we had stonefly. If you guys remember, they were in group 1, which means they're very sensitive to pollution. We know we have a lot of them, and so that was just a more reliable thing to go off of. And so I took my project and started focusing it on stonefly. So this is the basic anatomy of a stonefly. And one part that you really want to look at is this section right here. The shape of it is really important. Some stonefly have very skinny abdomen, some are triangular shaped. And so that was a good deciding factor when identifying these stonefly. Another part was the mouth parts, which is important because stonefly all have different roles, and there's a ton of different families of stonefly and each have a different purpose in the creek. Some are predators, some are shredders, and some are grazers. And so they're all gonna have different mouth parts depending on what they do in the creek. And so looking at this part, you can see it's kind of sharp and very aggressive. And so my best guess is that that would be for a predator. So here are, in order to get a really good look at these stonefly and to zoom in on the mouth parts and the different aspects, Mr. Sheldon was able to take me over to the Geneseo College in order to use their $35,000 microscope, and a huge shout out to Jackie Malinowski, because the software on this microscope was incredibly complicated. And we never would have been able to do it without her help in helping us use that programming and that software, which was really cool. So here are a list of all of the families of stonefly, and within each of these families, there's 2 to 4 species within each. So I'm only going to be focusing on these 4 families. There are the small winter stonefly, the rolled wing stonefly, the green stonefly, and the golden stonefly. And another thing you might wanna, or I'm gonna point out, is that all the photos I'm gonna be showing you from here on out, I took at the Geneseo College with that microscope, which was really awesome. So sensitivity. So pollution sensitivity was really important with helping us get this data for to see how the bus garage will affect this. And so within group 1, which was already very sensitive to pollution, stonefly range from 1 to 10, with 1 being most sensitive to pollution and number 10 being least sensitive to pollution. And as you can see, all of our stonefly range between 0 and 5, which means that these guys are very sensitive to pollution and are very susceptible to added pollution, and we're really worried that they're going to be affected by this new bus garage. So our small winter stonefly. Our small winter stonefly are found in the holaric area, which just means in this highlighted green section up there. They are shredders, which is important to think of when looking at the mouth parts. And they are tolerance 1 to 3, which means that they are just super sensitive to pollution. And so as you can see here, their mouth parts are more flat, which makes sense because they're shredders. They don't need to attack and go after other stonefly or other macroinvertebrates in the creek. So it was really cool just to get a close-up of their mouth parts. Our rolled wing stonefly. A big part that we looked at in identifying was this section right here. That section right there are the wing pads, and the shape was a really helpful part in identifying this stonefly down to the family. So the rolled wing stonefly are found in the holaric and the oriental area. So again, the green highlighted area, as well as this little orange section down there. They are also shredders, which means the mouth parts should look very similar to the other piece that we saw. And their tolerance is 0 to 0.7, which means these guys are super sensitive and we'll have to keep an eye on them for sure. And so again, like I said, this was a really deciding factor, as well as their hind legs. They don't extend out. They always stay pretty scrunched up in that position, which was really cool to look at. And it was a really big deciding factor in identifying these stonefly. And so again, as you can see, their mouth parts are more flattened and they have a very similar shaped mouth to the last one, which makes sense since they are both shredders. Our green stonefly. Our green stonefly are found worldwide. They are collectors, so their mouth parts should look slightly different than the other ones. And their tolerance is 0 to 1, which still means that they're still very sensitive to pollution. So here is a picture. As you can see, their mouth looks slightly different than the last one. All right, and here and right there are some of their mouth parts, which are used to collect that organic material that flows downstream from those leaf caps. And finally, our golden stonefly, which they are also found worldwide. They are predators, so their mouth parts should look more aggressive since they are meant to catch and eat other macroinvertebrates in the creek. And their tolerance is 0 to 5. So one thing to know about the golden stonefly is they're also called the common stonefly, the giant stonefly. They have all different sorts of names. If you Google them, this is what comes up when you search stonefly, which was just kind of cool to see that we did have these in our creek. And this is what is typically known as a stonefly. Here is just the ventral view of a stonefly, which I thought looked pretty cool. And it was cool to be able to flip them over and see the different sides of them. And then the mouth parts. And as you can see, like in that first photo I showed you of the stonefly anatomy, they do have more aggressive mouth parts right there and there. And then it's hard to see, but there are some peeking out right there. And so it's really cool to see the differences in the mouth parts and that these guys are predators. So in conclusion, we know that we have at least 4 different families of stonefly in our creek, and they range from 0 to 5 in the sensitivity tier, which is really important because our new bus garage may affect these stonefly and we might see a decrease in numbers of them or not the same families of stonefly. And so it's really cool to be able to see these guys. And in the future, we're planning on just keeping a really close eye on our creek. And so the last group talked about the bus garage. And so here's just a rough photo. That's the fire hall. And this is where our bus garage is planning on going. And so one thing that me and Mr. Sheldon were really concerned about was how they were gonna drain that runoff water, because since they have an above ground fueling system, all of that runoff with the water and the oil, and then they have a washing station and all of the salt from the bus garage, we were worried about that getting into our creek and affecting them. And so we had the landscape architect come and talk to us about their plans for this bus garage and what they were planning on doing with all that runoff, which they were planning on building a underground type of like chamber in order to filter the water, and they can control the outflow of water. And so they're planning on putting that right about there underground, and then they're going to ditch it and run the water out along this ditch. Hopefully it will have time to finish filtering out and the water will have time to cool down before meeting up with the creek down here at the culvert. And also in the future, me and Mr. Sheldon got permission to go onto this property in this orange highlighted section and look at the creek here. And so we're planning on getting samples further downstream, since as you remember, most of our samples came from this section of the creek. So it'll be cool to get samples further downstream in order to see how the bus garage really affects this. And here's just a list of my citations and some cool photos that weren't able to make.
Let's see if anybody.
Did you do a number count or was this just a survey?
So what we did to start was we didn't really have time to go through and count every species. So we more just went into seeing what we had, and in the future, I'm hoping on getting really into it and then doing these really precise samples where we can get numbers and exact species. But we have not.
Any other questions? So a couple of things. First off, I want to really thank all of you for coming out here. I appreciate your support for this program. And then I recognize this has been a long night, so I just want everyone to know that the Canisius Lake Association is honoring each of the kids who presented here tonight with a certificate, talking about how they appreciate their support for what it is we're trying to do. So I'll be handing these out in class. Won't be quite as official because it's coming from me, but just know it's from Charlie Braun and the Watershed Education Center. So again, thank you for coming out, everybody. We appreciate your support. Have a great night. Be safe.
Thank you. Thank you, everyone. Excellent job.